availability at this moment. But if you all students come to the campus, then I want to take your class offline in our seminar room. Do you know we have a seminar room in our department?
Yes, so for one of our courses, actually, we did have an offline class, which was also, recorded and shared on Teams as well. But for the
Okay.
students who were not on campus, but we did have one offline class as well.
So in that case, I will also start the offline class in the seminar room. So that would be better. And also, I requested the academic section to change the time schedule because 6 to 7 is not good time to teach a first year student. So that I don't think it's a good time. And all of you may not have sufficient energy to continue this class. And it's a very important class as per my point of view. So I don't think we'll take this class at 6 to 7 p.m. I requested all the academic persons related to this matter, this teaching matter. So I asked them to change the schedule, at least it or 4 or 5. So your they can reschedule your classes, means other two classes, that we can accommodate our class within this 6 p.m. So that my request I sent. But 6 to 7, it's not good time. Even this is our research time as per the concern of the IT faculties. So still, if it is not changed, still I will continue the class from 6 p.m. Um, that may be the at present this is the situation. So if it changes, then we'll change our schedule. Okay, so let's first check the syllabus. Syllabus is here. Uh, so it's analog electronics. So analog electronics is two part. In electronics, mainly we can consider two electronics part. One is the analog electronics, another is the digital electronics. Whatever you are now used in the laptop, etc. These are digital part. But to run this digital component, we have to, there is the basic is the analog part. And to understand the analog part, that you have to understand the basic of the device physics. That is the hardware part. If you want to modify any of this device structure, any of the analog characteristics of the device, so you have to know the basic of the how to modify how a analog electronic device is run. That you have to understand. To know that, you have to understand the basic semiconductor physics and how you can build a new devices. So if you know to build a new devices, and you have to consider the basic fundamental part of this device physics. So that is the semiconductor, or the knowledge of semiconductor metal, and then the connection of the semiconductor and metal junction, semiconductor junction, and semiconductor metal junction. If you understand it correctly, and then you add up some new science. New science means the at present we are dealing with everything based on the quantum, and so even to understand the semiconductor, we have to understand the basic of quantum mechanics. Then only we can able to understand the semiconductor. Without the knowledge of the quantum mechanics or quantum science, you don't able to predict the principle or the operation properties of a semiconductor. So to understand the semiconductor, you have to get some basic concept of the quantum mechanics, etc. So in this class, I'll first you just go through the syllabus. This is the semiconductor diode and basic diode circuits. Circuit is related, but if you want to understand the semiconductor diode, you have to understand the semiconductor first. So I'll start from the basic of the semiconductor. Then I'll go for the maybe I'll take maybe 5 to 7, 8 classes, maybe more than that. If it's required, I'll go for this semiconductor science first. Then I'll start the formation of the junction. Then I'll go for this the circuit analysis of the diode. Then the other is the bipolar junction transistor. That is the connection of the two semiconductor junction. That is the bipolar junction transistor. And thereafter we'll go for the field effect transistor. And this is the main part. Nowadays, whatever you are using in day-to-day life, electronic circuit, this is mostly based on the field effect transistor. In short, we call it the FET. Right? So field effect transistor is the semiconductor device part, and then this is the one part, then the amplifier. That is a combination of all those part, diode transistor or the other types of function. They combine and give you the one of the analog circuit, that is the different types of this field effect transistor or the BJT, bipolar junction transistor. We can apply this one for the amplification purpose or any other purpose. Then we'll analyze it in details how to use this transistor or in for application purpose, and then we'll go for the few part. I think here something missing. Okay, this is here. So operational amplifier op-amp. So it's a combination of several transistors. So we'll go for the op-amp part. Ultimately, if we have some time, we'll go for the oscillator circuit. It will take time to go for the whole syllabus, since I will add some additional classes related to the basic semiconductor science. Otherwise, it will take around 42 classes. Total is around 42 class. Sometimes it takes more classes, but in this case, I'll start first from the semiconductor science. So, do you have any queries related to the syllabus or thing you can ask?
No, sir.
So, then we'll go for the initial part of our syllabus. So maybe I'll stop sharing the syllabus and share the. So what do you mean by semiconductor? Do you have any idea? Do you have any idea what does you mean by semiconductor?
There are materials that
Please.
have some free electrons in them, and the electrons that are bound, the gap between the conduction and the valence band is also not so high. So it is like between conductors and insulators.
So you said some gap. Semiconductor have valence band and conduction band. Just schematic. Something like this. You have the conduction band. This is the conduction band. If you say simplicity valence band. So in between you have some gap. That you understand? All agreed?
Understood, sir.
So in there are three important parts. First, we have to understand there is some band gap. Maybe you have some idea. In my previous classes, means I took two classes, so I just give you some idea. Then in PHN 102 110 or 101, something that class. So that you have some gap between the uh, uh, between the valence band between two participating electron. Now here I will start the basics and in depth about this the transport properties of this electron. So now you have idea that if we have one molecule, one atom, first you consider you have the one atom. Um, we have this atom that contain nucleus. Nucleus, in nucleus, you know you have the proton number and you have the neutron number. And in general, number of proton and the electron presence in the atom which is rotating in different orbit, but this number of this atom, number of this electron, and the number of proton in general they are same. In general, they are same. So if let's say Z number of proton is there, so electron also Z number. If they vary, then you have different isotopic effects. I will not focus on the point of in that direction. So now you consider what happened to a solid material or any atom or the behavior of this atom in solid state, in liquid state, in vapor state, or its effect in inorganic chemistry, its effect in organic chemistry, or its effect in biology. All light is depend on the electron distribution in the outer in the this different orbit, electron distribution in different orbit. If you have, let's assume 8 electron is there, so 8 number of proton also be there, so that proton 8 proton should be there, and in general proton number and neutron number most of the cases they are same, but they may differ, but let's assume both same, so they will present in the nucleus. This Z number of proton positive charge will present in the nucleus, and neutron is a neutral charge, so it will not affect your distribution of this with electronic interaction. They will not participate. So electronic interaction mainly it's a Coulomb interaction. This Coulomb interaction will contribute for your any types of the solid state mechanism or the any types of mechanism present in the solid state physics, biology, or liquid physics, or chemistry, or inorganic chemistry or organic chemistry. All cases depend on this Coulomb interaction. Nothing else. So, what about the phenomena going on in the nucleus? You don't need to look at most of the cases. Maybe one additional correction may happen, but in general, this nucleus only have positive charge, JD. That you have to know. But nothing else. Whatever is going on inside the nucleus, that is the study of nuclear physics. But this nucleus, what is going on inside the nucleus, that will not affect your the physics of the physics, biological or physical, biological or the chemical science. It will not affect it. If you don't target, if you don't enter inside the nucleus, so you don't have to look at what is going on in the nucleus. So that if you want to look into the nucleus, then you have to go for very high energy physics. The energy, if you consider, that should be mega electrovolt, giga electrovolt, and so on. Very high energy. Mega electrovolt, giga electrovolt. These are the energy scale of this. But if you look into this energy of this orbit, electron orbit, this is the in the order of electrovolt, milli electrovolt, or micro electrovolt. This is a small energy part, and the nuclear physics is the high energy part. So if you want to study the nuclear physics or the interaction inside the nucleus, that is the strong interaction if you want to study, or weak interaction between this the different types of particles. if you want to study the neutrino etc. effect, those are in the very high energetic range. You have to look into this phenomena. But the phenomena happening in our day-to-day life, our body, or our whatever we are using in the or this spectacle or any material you are looking for, or the any liquid, any cosmetic you are using, all are just only the effect of this positive charge in the nucleus JD and the presence of this electron outside the nucleus in different orbit. So if you know that how they are distributed in the nucleus in the different orbit, and how this electron presence in the different orbit interact with other atom. It could be same types of homo types of atom or heterotypes of atom. How they will interact? If other atom come close to each other, then the electron, they can provide the electron to the other atom, or they can take electron from the other atom. Based on that, the whole mechanism of solid state biology and chemistry is lies behind all those phenomena. Now you have to understand that this nucleus, you just for this study for solid state physics analysis, you don't need to look into this nucleus. Sorry. So you don't need to look into the phenomena. Just consider you have a positive charge inside this. So you have JD now. Now, from the even simplest, if you consider the other model, then 2 electron can sit here. Then next orbit you have 8 electron. So distribution is 1s2, then 2s2, 2p6, where principal quantum number this one n equal to 1, here principal quantum number n equal to 2, and then 3s2, 3p6, 3p10, and so on. It will go on. This is the principal quantum number is 3. So for if one system have 8 electron, then this is how many contribution? 1s2, 2s2, 3, 2p, 2p4. So 6 electron is distributed. Now 2, 1, 2, 3, 4, 5, and 6. So if you consider this orbit can accommodate maximum 8 electron. 8 electron, 2 plus 6, 8 electron it can accommodate. Now here 2 can be added. So if this atom come close to the another atom which have somehow, I consider one at consider 1s2, 2s2, 2p6, 3s2. How many electron here? How many electron is here? 1, 2, 4, 6. 10 plus 2, 12 electron. Which atom this one?
Magnesium.
Electron present. Which atom?
Magnesium.
Magnesium 12. 12 electron. It's magnesium. This one, which have 8 electron. Which atom has
Oxygen.
8 electron?
Oxygen.
Oxygen. Oh. So this one have 8 electron and this one have 12 electron. It just consider. Now you consider if one magnesium atom come close to this site, what will happen? Nucleus, then 8, 1, 2 electron, then 1, 2, 3, 4, 5, 6, 7, 8, then additional. That's it. In general, in chemistry, you know that if this one, to fill this in orbit, n equal to 2 orbit, it's need 2 electron, then it's become a stable site. For this one, if it loses 2 electron, it will become 8 electron, so it's become stable. So in general, when they to come to each other, these 2 electrons go to here, or they get shared. So this become manganese, it lose 2 electron, so it's become -2, and it can oxygen gain 2 electron. So you can add this is positive, you can consider positive, this is considered -2. It can add 2 electron. This is the basic chemistry to form the Mg. Sometimes magnesium oxide you can grow. Of course, other higher order also occur, but magnesium oxide. This is one molecule. Manganese, a compound is formed manganese oxide. It can take 2 electron and it can. The physics, whatever is going on in the world for material science or chemistry or biology, this is transfer of electron from one side to the other, or it's gaining of electron from other to the one atom. So this type of phenomena is going on throughout all the material point of view. Any material science, I say material science means solid state, inorganic chemistry, organic chemistry, biology, or in the material science. So this transfer of electron is most important. So what is going on in the nucleus, you don't need to take care of. Just you can consider the electron is it's coming out from a material, from an atom, or it can add it to an atom. This is the phenomena is going on. And you throughout this point, the material science, you have to control how to transfer this electron from one side to the other side, or you can gain one electron from one side to the other side. This is the phenomena you have to control. But for atomic point of view, you have a single atom, you can understand 2 electron can go from one side, or 1 electron can go from one side, and it can 1 electron can accommodate by the other atom. But if it is a solid, it's a large number of atoms is here, then you cannot simply say 2 electron can go from here, or to other 2 electron can come. Then you have to understand the mechanism. If a large number of atoms are there, what happened to that material, to that element? If a small element is there, single element is different, or single atom of single element is different. But if it's a multiple numbers of atoms combined to each other, they present in somewhere, then physics or the chemistry is not so simple. Then you have to understand they will change their mechanism. They will give the average effect of all this electron, and then you have to find out some mechanism to control that how when this large number of atoms are there, then how they will modify this mechanism of simple 2 electron. You have to measure this number in general in solid. We measure this one by the chemical potential of the system. So chemical potential not is but the measure of this electron, free electron. It can provide how many free electron to other, or it can accommodate free electron from other. That you have to measure the average effect. Average effect can be measured by the chemical potential. In general, it's commonly used by the chemist people or biologist people, chemical potential. It's mostly used in chemistry or biology. Of course, in semiconductor physics, there is slight difference between chemical potential with the other terminology we want to use. They somewhere it could be same, sometimes it may differ, but chemical potential in general in semiconductor physics will use another term, that is the Fermi level. This is the important. Both are almost same, they have different. But in semiconductor science, we use the terminology chemical potential, mu. This is very important. So this is the effective of this atom, when they lose the electron or it can accommodate electron, that will determine this chemical potential or the Fermi level of that system. Fermi level is a measurement of the averaging effect of this electron in that particular material. So how this Fermi level can be defined and how they will affect the other material, one atom to the one types of material which contains different types of atom, and means a large number of atom. It could be same types, homotypes of atom, or it could be heterotypes of atom. Something silicon, it's a homotypes of solid silicon, bulk silicon. Consider bulk silicon. It contains homotypes. All atoms are homo. Same types of all are silicon. If I consider another solid material, if I consider gallium arsenide, this is hetero. Hetero atom, it's different hetero types of atom, different element content. These are called compound semiconductor, or if it's a semiconductor, we call compound semiconductor, or the material you can say, because this is semiconductor, I give it semiconductor. These are the elemental semiconductor, elemental semiconductor. This is two types of semiconductor. One is elemental, one is a compound. Other example of the semiconductor which are the elemental is germanium. And different carbon have different components, but mainly I can say silicon and germanium. These are the elemental semiconductor. Or compound semiconductor are different: gallium phosphide, gallium nitride, aluminium, gallium arsenide, gallium arsenide phosphide, indium phosphide, zinc oxide. These are manganese oxide. There are so many: gadolinium oxide, Gd2O3, gadolinium oxide, Gd. There are several types of compound semiconductor are available. So now you have to understand how, if you want to make material, you want to make some device. To make these devices, you have to know this material, silicon. You have to know this material, germanium, in bulk and in the atomic structure point of view. Both way you have to understand how you can deal with it. Because now the old semiconductor devices, these are based on these properties of the individual, means bulk semiconductor. But nowadays, whatever we are dealing with, all this laptops content the effect, not only pure bulk effect, it have the effect of the quantum effect or the atomistic effect. If I say atomistic effect is there, so whatever we are dealing with the laptop. In my laptop, this laptop, what I'm teaching now, the transistor size, what I said that FET, field effect transistor, the size of this transistor is 10 nanometer. This laptop contains the 10 nanometer. 10 nanometer means the effective area is 10 nanometer. It contains around 11, one line, 11 atom. 11 atom in one's lengthwise, it has 11 atom. Average of the order of 11 atom is there. So that whatever is running majorly by this 11 atom transistor, you can consider. People are growing, so around 6-7 atoms, so 3 nanometer node should be the ultimate target nowadays. These are not, if you have the 3 nanometer is around 7 atom is there, around 6 to 7 atom should be there. In the size, in length, 6 to 7 atom there. Here 11 atoms is there, 10 nanometer, around 11 atom is there. So here 3 nanometer scale is 6 to 7 atoms. Now you consider in the bulk, there are, if you consider 1 centimeter by 1 centimeter in length, 1 centimeter to by 1 centimeter, just simply I consider into 1 centimeter 3 by 1 centimeter cube, it contain around contain around 10 to the power 23 atom. 1 centimeter by 1 centimeter by 1 centimeter, one means cubic centimeter. If you consider one box, cubic box, then the atom number there is 10 to the power 23 atom. But here you consider that the ultimate target of the transistor that should be built, I think, at around 2020. The earlier it was planned to 2022, but I think around 23, 24, or 25 it should be finished. 3 nanometer transistor, that is the 3 nanometer node size can be possible to build. So 6, 7 atom. Now you consider 10 to the power 23 atom interact to each other, whatever the properties should be there. Now if you have only 6 to 7 atom is there, so their effect is completely different. This one will show a bulk effect where large number of atom are interacting. Here you will get 6 to 7 atom, they have the molecular effect. If you consider, as I said, what we are dealing with, that the energy scale I talk about here in this bulk effect, this bulk where you consider 1 centimeter cube size, here the energy spectrum, if you consider molecular energy spectrum, that of course I will give you the how to calculate those. I will go for in details how to get this spectrum, how to you can numerically calculate the exact value. So I will build those formula one by one. This scale bar, if you consider in the bulk, the molecular level, molecular splitting energy level between conjugative energy level, it's of the order of femtoelectrovolt, 10 to the power minus 15 electrovolt. And if you deal with 6, 7 atom, this spectrum should be few electrovolt. It could be 10, 12, 1, 10, 12 electrovolt. Around it may increase depending on the different types of atom. So few electrovolt level, this spectrum, this energy difference in the bulk should be 10 to the power minus 15 electrovolt, and in the energy scale in the molecule 6, 7 atom is there, if the spectrum become 10 electrovolt. If simply you consider 1 electrovolt, if you consider how much large this one compared to this femto electrovolt, can you compare it? How much large it is? No idea?
No, sir.
No idea.
Yes, 10 to the power minus 15 is very insignificant as compared to 1 electron volt.
That means it is 10 to the power 15 times larger. See? You heard about 1 million. 1 million is 10 to the power 6. See? 1 billion is 10 to the power 9 times larger. Then 10 to the 12. Then 10 to the power 50. How large you can. This is trillion. 10 to the power 12 is the trillion. More than trillion. This is the order of how much is big. So if you consider its distance from here, if you consider to I think more than moon, some star distance, if you measure in kilometer. So in that scale, it should be very large difference. So this is the bulk system. The molecular energy splitting level, conjugative energy level between this molecular spectrum is femtoelectrovolt, whereas this one I consider 1 centimeter this atom, and here if you consider 6, 7 atom, this spectrum should be few electrovolt. So the effect is very significant. So that's why bulk and the atomic level interaction, molecular interaction are completely different. It looks completely different, but it's not like completely different. Both are same. They are interacting similarly only due to the effect of large number of atoms. They become very small, and if a small number of atoms, their interaction looks very strong. But the mechanism behind this 10 to the power 23 atom and the mechanism between this 6, 7 atom are same. Only what is happening there, the interaction between this external electron. Some effect from the inert electron may happen, but mostly if you consider if if I consider this nucleus, this is one internal orbit, this is the outer orbit. If some electron are present in the outermost cell electron, we call the valence shell. So this valence electron and the other atom, if it's a maybe different or equal number, they are field state and these are valence state. So this interaction of this electron to this valence shell electron is the only mechanism behind this splitting of this energy level, or the energy spectrum is built by this interaction based on this valence band electron. Mostly this is the effect of this valence band. But what happens if it's a valence band electron interaction? Which types of formula you want to use? Can you give me the idea? If electron of one atom, it's maybe the external or outermost cell electron, if I say, if they are interacting to the other electron, that is the mechanism. Okay, so which types of formula you want to calculate to check the effect, the building effect, or the interaction or the interacting force? Which types of the interacting force you want to apply between these two atoms? Do you have any idea? No idea?
Coulomb interaction.
Coulomb interaction. Coulomb interaction. What is the formula of Coulomb interaction of Q1 and Q2 atom? What is the interaction formula?
A Q1 Q2 by R square.
Q1 Q2 by R square, some constant depending on the which types of formula you use. That's so Q1 Q2 by R square is the force and potential is K Q1 Q2 by R. This is the potential. Okay? Potential is a measurement of energy and this is the force. So this is the only thing it's happening to the material. So you have to know, if you want to study this material, so you have to know this potential. What is the potential to this material? So you have to study this material individual atom first, and then you have to study the interaction by doing the interaction between this atom to other. So when you can simplify some part. First you have to study one atom, and that you can use the Rutherford model that I taught earlier, and you know your HS level you can understand that what is the Rutherford model. So using that you can get the average effect. You can modify this effect by using the Schrodinger point of view. Slight modification will happen. So this is not exactly spherical, but it's not circular path, it may be the elliptical path, or actually you can find it is not actually, depending on the different orbit. S orbit when L equal to 0, your S orbit is completely like a sphere like a football. And if it's a P orbit, it's like a dumbbell, you use the dumbbell. So it's a 3D structure. It's something like in 3D, this is dumbbell. So in 2D, in S orbit, it is sphere. That means electron cannot sit only in a circular path. In Bohr orbit, you consider it's a circular path. No, it's not circular. It is a sphere, football. So electron can sit anywhere in between this sphere. Anywhere in the sphere, if you consider any position, it can sit. That is the sphere part. So in time you change. One moment you measure, the electron is here. Next moment it can be here. In the sphere surface, it can stay anywhere. If P orbit, it's a dumbbell. So in dumbbell surface, anywhere it can present. So you can measure one time it is here, next time you can find here. You can do the averaging of this measurement, then you can find it's a dumbbell like shape. This is then the higher orbit, D orbit is the other type of structure. So S orbit, D or P orbit is like this, then the D orbit is the different types of structure you can find. So this is actual thing. Now you have to understand that this S orbit, P orbit, how they will interact. Now additionally you have to check this Coulomb interaction. Individually you studying this electron. Now if you want to check this 2 electron is here, Here, if they are same atom, then you consider 2 electron is there. So I can use this 2 additional electron. You can ignore the inner part, maybe for your simple study, if they are not interact to each other. I will explain you when you can able to ignore it, when you have to consider it. Now these 2 atoms, what is the, then it's I measure the atom 1, atom 2. Okay? So it measured E1 electron, first electron, this is second electron. Then this is the E1 electron for the second atom, the E2 electron, the second atom. So this is first atom. So you can use the suffix here 1, 1. This is 2, 2. You can use this suffix 2. Now you can build the interaction. What is E1 electron of the first atom can interact E1 electron of the second electron. A is constant, I can taking outside, then the distance between these two are 1, 2, 1, 1. Then these are electron, electron are the repulsing force, so it's a positive. Then E1, it's 2 electron, then 2 are 1, 2, 2. Then E1, 2 of E1, 2 are this is 1, 2, 2, 1. This is 1, just second. Then E2, 1, 2, E2, E1, 1 is the suffix, no, this is 1, sorry. This is 1, this is, one moment. First atom, second electron, this is. First atom, second electron. Second atom, second electron. 1, 2. This is the Coulomb interaction. 4 types of Coulomb interaction you can get from this 4 atom. This is the polar positive. This is positive or repulsive Coulomb interaction. Coulomb interaction. Now, what is the additional part you have to consider here? Another important part you have to consider that this nucleus and this nucleus, they will give the repulsion to each other. So if I say same type, so ZE, this is also ZE. So you get another repulsive force you can add up here, that is due to this nucleus. Z squared E squared by nucleus, I mentioned it's N 1, 2. Nuclear distance. Now the another thing we have to consider, this nucleus will attracted by this electron, these 2 electrons. This is now positive charge and negative charge. Positive charge, negative charge. These are the, now you have to consider the positive charge and negative charge. That is attractive Coulomb potential. Now your first electron, I consider Z1 first to mention 1, 1, 1. Now second electronic interaction, Z2, 1. But our first nucleus and the electron of the second, 2. This is the first one. Then the first electron Z1, then E, this is 1, then E2, E2. Distance between the first nucleus ZD position to the second nucleus, second E2, this is E1. Then the reverse part, you have to add the second nucleus. It's a very complex. Now this nucleus to these 2 electrons. So you have to add. This is all total potential. So you have to add this interaction between this. Now we ignore this interaction in between because this electronic interaction and this one is already considered to make this cell structure, different cell structure. So your total part is now, if we add this also negative potential, so if I say Z2, second electron, Z2, now first one, electron 1, then R2N, 1E1. Then the next one is Z2, E1 to R2N, first electron. This is your all interaction if you want to study this part. And of course, it's simply calculation this part. You can find that these two parts should be only simplification. If I did, these two parts should be the same because same atom. So you can just only multiply this by 2. Then this one also, these two should be same. So you can ignore and you can just multiply by 2. You can get this. Are you saying something? Do you have any queries? So this is your, of course I have to zoom it because it's very big, writing is difficult. That's why we need the offline class. Sometimes it's look difficult. So you have this, the same types atoms. So these two interactions should be same. So it should be only multiplied by 2. You have this part, you have this part, and you have this part. So you have to solve this for 2 atoms. If you solve this one by 2 atom system, then you can able to calculate the what is the exact interaction part. And you have to do this one. We have the process to solve this these types of calculation. Then only you can able to get the exact value. What it's the amount of this energy interaction between these 2 atoms. You can able to calculate. So this is the exact process. And if you now you can understand that if 2 atom is there, then you have this, so many additional this part of Coulomb potential is coming. If you have multiplied 3, then you can consider the 2 to the power, or then 3 to the power 3 times will increase, and in number of atoms, then interaction become more and more complex. And then these types of calculation would be very difficult. And then we have to do these types of calculation. In reality, we need high computational power. First thing, one computation. Even if we want to take 1,000 atom and consider all electronic interaction, just considering the external electronic interaction, even nowadays supercomputer will take almost 7, 8, 9, 10 days. If we consider the all atom interaction, just you consider this all atom, then the additional interaction between all the internal atom also, then supercomputer will not able to calculate these types of problem. So in general, to do this earlier, we don't have the computational facility earlier. We have to do several approximation to deal with. So last 100, 200 years, we will try to modify the physics with the averaging effect, and they give some complex, some approximation to do this calculation. And later on, we can able to get the exact result. So even in this case, even if you want to run in this, yes.
लेकिन मैं जा रही हूँ 7 बजे यूबीए के काम से तो आ जाना
If you have able to please, if you have some talk to in between yourself, please keep the mic switch off condition. Okay? So you should mute yourself before talking to each other. Otherwise, it will disturb the whole class. So this interaction is very important. So you don't able to calculate this whole mechanism even in the supercomputer. So if you want to consider some interaction in biological molecule, one big biological molecule is around few lakh, 1 lakh, 2 lakh, 3 lakhs atomic content, and solid is 10 to the power 23 number of atoms. So these types of calculation is almost impossible by supercomputer. Even nowadays, if you want to calculate exactly about the just considering the averaging effect of the electron in the outermost cell, then even we need for large number of atoms, we need the some additional computation facility. Even supercomputer cannot able to calculate the exact calculation. So in that case, for large number of atoms, we need the next generation electronics. That means we have to go for the quantum computer. This is the direction, this is the future to deal with better calculation, better result, to understand the molecule, to understand the solid, to understand few atom physics. So if we are able to understand these types of mechanism to deal with, we need this energy spectrum for different atom, different molecules, then we need the higher computation facility. And this is the future. We have to build quantum computer. Supercomputer will not able to calculate large number of atoms. Even in case of the biological molecule, organic molecule, they don't able to calculate the exact spectrum. And that spectrum is highly needed to develop different types of drugs, to develop new types of molecular understanding of our body's problems, some cancer cells, some virus body, or the bacterial. If you want to understand, if you want to develop new types of drugs, and for that case, this types of spectrum is very, very important. Without knowing this spectrum, you cannot exactly able to design a new drug. It could be we are doing some trial and error method to get the exact result. If you understand the exact mechanism, then that, as I said, the electron transfer to one system to other, or to transferring or accepting electron, that is the main mechanism of any types of the material science phase. Material science means the material world is involved only the electron transfer or the acceptance of electron. That if you understand that, to deal with or to play with that the mechanism, you have to understand that this the energy scale or energy spectrum of this molecule or the atom or few atom system. Then we need this future is the quantum computer is the only solution for that part. So what is I want to explain this mechanism, but I just give you the some hint. What is the future? Even to do the any types of future or effect, to study the environment effect, to study to develop new drug, new cosmetic material, or some effect in the future astrophysical phenomena if you want to study, or the cloud mechanism you want to study, or you want to study the mechanism of this the tornado and other types of cyclone. If you want to study, then high level computation facilities required. Even supercomputers don't able to solve some of the problem. It will stop. It took long days. Even supercomputer failed to solve such types of problem due to the memory effect, low level of memory. So in that case, if you want to do such types of struggle, quantum computer is the future, and that I can say this is a part of your hardware development, or the modified version of the analog electronics. This hardware development is required, or the analog electronics need to be modified. Of course, it directly used as a digital. The quantum computer is directly work as a digital part, but the hardware development is highly required. So this is the future of the hardware, or that I'll start to explain in the next class. So to understand this, to build this quantum computer in the next generation, next 20, 30 years in the to develop, we have to develop this quantum computer. To understand our day-to-day problem, the mechanism is highly required. Otherwise, will stop. As I said in my previous class, just few times back, I just said that 3 nanometer is the target of this present day technology, and it should achieve soon. Within a couple of years, it should be achieved. Then we have to, so we don't able to increase the speed of the computer, and then we need the future is quantum computer. Of course, few companies are working low temperature physics, like using the supercomputers. I mean superconductivity. People are using superconductivity. Superconductivity. People are D-Wave, one company, and the Google, these two companies are making the low temperature, millikelvin temperature, or quantum computer. They are already built. Of course, different ways going on. Almost 14 processors working on to build the quantum computer, but few are working very low temperature is working, some quantum computer already built, but we need some modification for high temperature physics is also important in that case. So this is the future. Who are interested to develop the further in this field, you have to understand this type of mechanism in the future. You can work on. So I next day I'll start how you can to build the basic logical circuit. To build this basic logical circuit, basic analog circuit, you have to understand how the material works. So I will start from tomorrow. That from maybe from the next class I will start how you can understand a semiconductor, a solid state material from point of atomic interaction. Okay, let's stop here for today. In the next class, I'll start I'll try to explain you the how semiconductor work. If you have any queries, you can let me know.
Thank you, sir.
Sir, I want to ask this, the class from which actually held from 6 to 7 today, was just a random class, na? It was not decided before that.
Still now, this is the schedule. Next class also
Okay.
in the same class. I requested Dean Academics and the other means DR of Academics also, and also the DFSA chair to modify this schedule. But I don't know. This is the schedule from the institute they give to me. I requested to change it.
Okay, sir.
Sir, I think it is because of some complication with the timetable because
Yes, because this
like
this one made by, I think that this is the mismanagement of the maybe some of the when they are dealing with these two batch they did not consider some mismanagement is happened, but I requested to rectify it, but I don't know what will happen at this moment.
sir, so I think the issue was that the 5 to 6 slot. So the timetable which we received in that on Monday, Tuesday, and Thursday, the 5 to 6 slot was reserved for your analog electronics course. But I think
That
you
may
do.
be no, the other batch. There are two batch. One is EPH and one is BSMS. BSMS have class from 5 to 6.
It's actually called like it's both of us actually have it. Like EPH and MSP, both of us have it together only.
So this class is together, but from the mathematics class you have separate class. Am I right?
Yes, sir. Yes, sir. Like
That's the problem. The
It's from
EPH
5 to
have the
6.
mathematical class from 4 to 5, and BSMS group have the mathematical class from 5 to 6. So one class, one of this mathematical class to be coupled means to be shifted to 4 or 5. Then only 1 hour should be vacant.
okay, sir. I'll also look into it from my side.
So if you request your mathematical professor that to sit one of the class, maybe 4 to 5 can be shift to 5 to 6, or 5 to 6 can be shift to 4 to 5. Then only it's possible.
So I think for this week we can continue with the 6 to 7 until we find a
I know this is
solution.
very problematic, and I requested Dean Academic from my side, but from it is not possible from my side. If they did not give me the slot, then it's impossible from my side to change. You can send the same email to Dean Academics, then it's possible.
Okay, sir. We will send it.
So from your point of view, we can send the mail. Then they will try to couple some of this the mathematical class. They may shift one of this class. Then only should be vacant. Otherwise, it's not. From me, it's not problem. I consider it's a energetic point of view. You have some problem because this is order. We are researchers. We don't have any problem because we are continuing this research up to 8, 9, even sometimes more. Okay, regularly, we are working even in the lab up to 8, 9. So it's not a problem for us, but it is problem for you. You are not habituated with this the schedule.
Okay, sir. Actually, I just went through you. I'm just going through uh, the given timetable for both engineering physics and MS physics. There seems to be a little bit of controversy, like regarding when I'm seeing the BSMS physics timetable, for them it is not showing an analog electronics course. I don't know why.
They have this class BSMS.
Yes. Okay, I'll try and talk to some people from the BSMS as well and figure out what exactly is going on.
So you can figure out if it's possible. You can shift it. If one of the mathematical class need to be shifted.
Yes. Okay, I'll look into it. Okay.
Okay.
So bye.
Thank you. And if we have some time, you can think of the offline class. If all students come next week, I want to take the next offline class.
Yes, sir. Next week onwards, I think.
No, as per the new notice came to us that it is first year student don't have the offline class at this moment.
But I think for most subjects, offline classes are going to resume. So
So
for
I
Yes, sir.
take this class in the seminar room. So it is from my responsibility to arrange the class. But
for
from
this
the
week, I think
academic,
we can for this week, like this week till this Sunday, we can resume in the regular online mode, and then we can shift offline from Monday on.
yes, yes, yes.
Okay, sir. Thank you.
Okay, welcome.
Sir, can you tell what's the timing for the next class?
6 to 7
No,
online.
no, sir. On what day?
In the Thursday, as per the schedule is it is Thursday.
And Thursday and Tuesday.
Thursday, Monday, Tuesday. Three classes per week.
Okay, sir. Okay. Thank you.
Okay, best wishes from my side. A good night.